Greetings to all.
The topic of the presentation is discrete cosine transform based Fourier analysis to fuse multimodal medical images.
We are going to present a novel multimodal medical image fusion rule which is essential for medical treatment and diagnosis.
Here we have studied a fusion approach based on DCT followed by DFT. In our fusion rule, the source images are decomposed using NSCT and the low frequency subbands are fused by DCT followed by DFT, whereas maximum selection rule is applied to fuse the high frequency subbands. Simple averaging technique is used to fuse the amplitude part of the image.
In this slide, the details of the type of modal images considered for experimentation in MATLAB is presented. The resultant fused image has a better subjective and objective aspect.
Now, in order to improve disease detection, images of different modalities are fused. This fusion helps us in retaining the finest details and improving the contrast of the image. The commonly used modalities are MRI, PET and SPECT.
NSCT decomposes the images in the form of contour segments. Therefore, it can capture geometrical structure of an image in more efficient technique than other existing wavelet techniques. Here, a flowchart of NSCT is presented, which shows it is an amalgamation of non-subsampled pyramid and non-subsampled directional filter bank. Here, DCT converts an image into its equivalent frequency domain by partitioning image pixel matrix into blocks.
Here we have studied DFT method on the image to obtain the amplitude and phase spectrum. The amplitude spectrum carries information about the relative dimensions, while the phase spectrum reveals the relative position of the image components with respect to each other.
SVD is an attractive algebraic transform for image processing application. It is a stable method to split the system into set of linearly independent components, each of them bearing own energy contribution. This is the pictorial summary of the proposed algorithm by flowchart.
Here we are presenting the first set of results that are obtained by the fusion of PET and MRI images. From subjective analysis, we can clearly see that the image obtained using the proposed fusion scheme preserves the detailings and color saliency is also better compared to other fusion rules.
Here is another set of fusion results, that is SPECT and MRI. We can observe the resultant fused image by other traditional fusion rule suffers lack of visual clarity, degrades prominent structural differences, and introduces artifacts and inconsistencies. These characteristic information is well preserved in our method. The quantitative matrix also suggests the same, that is, it is higher in case of our proposed method. Here is a summary of our work as stated previously and further work. These are the references followed. Thank you.
Thank you.